Long stream today because we got no dog here, and go back to long streaming for a change. And guess what, baby? We are so barack next week with long streams. I gotta put in some work, man. We gotta get back to the regular schedule. I'm ready. I'm ready. I'm ready. Let me switch the YouTube stuff over to gaming. All right, so we're back over to KSP. Let me just splash the title screen here real quick so you can find it in the VOD. Give me 1 second. Nova, you're gonna miss tonight's Friday night racing. You have to take your mom to the airport early tomorrow morning. Good on you for being responsible. Good job. All right, let's roll. Ah. Oh, dude. That's so pertinent to the conversation that I was just saying. All right, here, check this out. So what I was just saying, listen, this is awesome. What I was just saying is that I hate doing troubleshooting on stream. The reason why is because in the back of your mind, you're kind of preoccupied with making sure the stream health is okay. Is my mic muted? Are we on the right scene? Have to look at chat. What if somebody in chat wants to talk about something else? It's hard to do troubleshooting on stream. That's hilarious that the mic was off. That really makes me laugh. Can't make this up. Anyway, really, I'm really happy it's Friday. I'm not gonna lie to you. So when I try to do troubleshooting on stream, we're operating on like limited brain capacity. Basically, I'm like full boomer when I try to troubleshoot. Okay, now what do I press? You know, it's bad. It's bad. Oh dear. All right. That's funny because that's very pertinent to what we were just talking about. All right, that's an easy one, boss. Yeah, you always say that. You always say that. Oh, it's easy. Just go into the registry, delete the registry file, restart, reinstall drivers from the CMOS, blah, 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 blah. Yeah, that's an easy one. Yeah, sure, of course, it's an easy one. Search for wind tunnel. Kerbal wind tunnel from boot. Now what? Versions tab on the right. Settings, compatible. Tick the top right one. This one right here, 1311, install. All right, fellas, I have to use the restroom real quick. I will actually be back in a moment. I've decided. I gotta go. I gotta go poopy. I'll be right back. I gotta go poopy. Oh, man. I had to take a wicked number 3. I'll take 2 number 9s. A number 9 large. Number 6 with extra dip. All right. So, did we get this all? We serve food here, sir. I'll take a 4x4 on a raft. No pickles, burn it and let it swim. 4 fried chickens, Coke, some dry white toast. Apply and play. Apply changes. Kerbal wind tunnel. Apply. With a shimmy and a squeeze, burn it and let it swim. Serve food here, sir. Fresh. Get rid of that. Put that down there. Go up here like this. Let's see what this wind tunnel thing is all about. Did you wash your hands? After a number 3? Oh, yeah. Lemony fresh. Yeah, seriously. That's, yeah. Number 3. It's no good. You don't want to hear about that. Pretty sure. Decontamination shower. I'm not saying we were at that point, Aranor, but we were almost at that point. I'm not sure how to work on Dart. Yeah, we'll see. We'll see. You know, somebody suggested the other day using ferrums, and I'm like, give me this shake, burn it, and let it swim. Still no pickles! Mr. Krabs, I can't do anything right because pickles. So, what is a wind tunnel really used for? Well, a wind tunnel is used to validate aerodynamic calculations in smaller scales, right? You know, for instance, if you just need to make a wing for an airplane, right? You're just making a wing. You're not making the whole thing, right? You just make a wing, you put it in there, or airfoil shapes. Or you could use a subscale model of the entire stack. The wind tunnels are basically used to validate calculations. The reason why is, well, the same reason as what we always say. It's, and what frankly any aerospace engineer will tell you. It's really hard. You're not going to be able to compute exactly how something is going to fly. The mathematical equations are unsolved, and they will remain unsolved for a good while. Are we bringing home the other Grissom? I just got rid of it, Chief. I got rid of that. I really want to erase any parts of that mission because it was the send-off mission for a game that doesn't exist. So there's no reason for it to exist because we just took a hiatus from Kerbal since February of 2023. That's all. How dare you suggest otherwise? It's like the Mandela effect. You know, like the Mandela effect. Let's get the tunage going. All right. How do we use this? Let's figure it out. Ferrums jack up the CPU cycle something awful. I've tested it too. Over multiple cores, or is all the physics still simulated on one core, Tessa? One core as usual. All right, take a look here. Just one more core, bro, please. All right, let's take I was about to say, let's just take a regular plane and put it through the wind tunnel, but you know, how about the Curb Air 990? A really just nice little small plane to fly. So, what is this gonna do? Whoa. Ah! Oh! Oh, all right. Yeah! Dude! Cool! They're gonna do this real quick. What's that? Sorry, Truthful just replied to that grammar abomination of a tweet that I said. I'm sorry, that made me laugh. God, I'm such a numbskull sometimes. You know, the next time, you know, I say I'm an idiot and people say, no, EJ, you're not. I mean, all right. EJ, I'm trying to build a simple plane from the tech tree for science mode. How can I use those simple engines? Can't seem to know how to attach them or use them. What I do, or what I did, was use these parts. I use these to make a small jet engine. Silly question, can you attach a rocket to this plane and send it to space? No, this plane was not designed to do that. So what I did, dude, was take this thing, the duct, and I used that to make an engine. I find you get much better balance this way. I'll give you, let me show you. So I took that, because you could just attach these, you could surface attach them to anything, right? So you take that, put an intake on the front, and then you go into engines and you put a little Juno on the back. And it makes a little jet engine. Now, a little word on this. This is really good for a plane design. The reason why it's good is because, well, a lot of people, and this is kind of a meta, would take the fuel tank, right? And they would make the engine that way. I don't like having my engines hold fuel. Engines don't hold fuel in real life. A fuel tank does. Usually wouldn't have a fuel tank in line with the motor. So I use this design, and that enables you to put your engines wherever you want, Smoked. All you got to do is just put your fuel tanks near your center of mass. Like, put them in the wings or something. And you can make a pretty good scientific research plane. I don't think I have that unlocked. I guess I can't use it then. Oh. Well, then just use the fuel tank and just keep the fuel tank empty. That's all. The nacelles, I believe, these fan shrouds are from Making History, guys. I'm pretty sure those are from Making History, along with some of these propeller blades. I think. I don't really remember. It's been a long time. All right, so Kerbal Wind Tunnel. Let's flight envelope. $5,000 meters at 250 feet a second. Level flight angle of attack is 1.21 gigawatts.
Oh, this is space. I'm in space.
All systems gifted 5 subs. Thank you. Appreciate it. I'm just asking, yeah, Journey, if I put a rocket on it and the rocket was lined up with the center of mass, sure, why not? You'd have some trouble during re-entry, though. These wings don't like taking heat. But yeah, sure, if I put a big enough rocket on this, you could send whatever you want into space in Kerbal. There's not as much emphasis on the material science. The material science in Kerbal 1 was always abstracted on purpose because of the difficulty. That having different materials would open up a bunch of options to make different things, and that would be kind of cool. But for all intents and purposes, every part is made out of mostly the same metal. I'm guessing every part is made out of aluminum. I had to throw it out there. Yeah, no problem. All parts in KSP are made out of explodium. Given the bad mass fraction on most parts, Panta, I think you could also conclude that parts in KSP are made out of solid rocket propellant. Metallic SRB, because everything explodes. I think one of your other mods is interfering. Interesting. Wow. Huh. No, this plane is not designed to go real quick. It's really not designed to go any faster than about 300 meters a second. I designed it that way on purpose. Huh. Guess who's freshly 21 today? Happy birthday, buddy. Huh. Alright, hold on. I have to understand how this all works, guys, so that's why I just wanted to load up like a regular plane. Let me see if we have just a more garden variety plane than that thing. Screw it. I don't have any regular planes loaded into this, so we'll try to break it. Hold on to your butts. Oh. Oh, God. That is... This is lift to drag. So the ratio of the amount of lift we're creating versus drag, 4.5 to 1. That's cool. Let's see what the drag force is. I bet you it gets super red right up in here. Oh God, that flight envelope is terrible. Oh. Oh, yeah, this won't take into account the hybrid tech elevons. Yeah, for sure. Oh. So guys, this thing that looks like a guy kind of hunched over from the side right there, that looks like that's the flight envelope for this thing. Not great. Not great. This, yeah. Oh. Yeah. This thing will only really get into runaway thrust at 10,000 feet for a very specific spot. After that, you're losing thrust. This basically shows what we already knew. Star Raker can get, initially it makes tons of thrust, gets way up to speed, right? But as we gain altitude, right? Like, see this line is where it really can and can't fly. Once again, that's not, Aqualex is right. It's not really taking into account my hybrid tech surfaces, but I guarantee you, even with the hybrid tech surfaces, it's not much more than this. And that's based off of the flight data that I've seen. So what I'm showing here is all the different places where the engine, so this is basically how much thrust the Shrubber engines, which is the turbo, high bypass turbofan ramjet design that we made, the Shrubber motor, inside of the dragless fairing. This is the places where it generates the most amount of thrust. You have your speed down here and you have your altitude here. This thing will generate the most amount of thrust right at around 7,500. Actually, right at about 5,000, it generates an amazing amount of thrust. 7.6 meganewtons. 500 meters a second. But as we go up, see, the thrust tails off. But it stays, actually, it stays pretty good. Yeah, that's actually not bad. But yeah, this basically shows what we've been seeing. Every time I've launched Star Raker over the past couple of days, we get right to around 600-700 meters a second, and it can't go any faster. The drag just becomes too much. Like, let's look at the lift to holy sh. Okay. Anywhere that's blue, anywhere that's not yellow, green, or red is bad. Is bad. That's bad. That's very bad. What would be ideal in this particular graph is for my flight envelope to look something like this. To look like the area that's greenish right there and follow that. I kind of got it right, but it's not right at all. Hey, Max, what's going on? Oh, jeez, that's poo-poo. That's doo-doo caca poo-poo. Pee-pee. Can you make a stupid simple plane to test this with? Yeah. I'll pull one that I already made. I'll pull one from mission mode, from the original mission mode. MM2 save. Saves, MM2, ships, SPH. The A200 was a very, very simple plane made with simple parts. So paste that in here. I just copied the entire... I definitely didn't do that, but that, you know, it's fine. Do you ever play KSP 2 still? No. The Ghostly, can't really say for sure, but let me just say that the entire development team that was working on that got fired. They got laid off. So I can play KSP 1, which is fairly feature complete, or we can play KSP 2, which isn't. What, dude, we don't even know what happened. Whatever did happen was so bad, we never heard about it. They didn't even tell us. They didn't even bother saying anything. They just said, no, bye. Actually, you know what? They didn't even say bye, to be honest with you. So, last if you can, sorry. So, yeah, I don't really play. I'm probably not going to play KSP 2 ever. I, in fact, choose to acknowledge that game does not exist. I refuse to acknowledge it. Quick question for tonight. Do we want to go with just LMP2, just GT3, or just GT3? No multi-class. No, just GT3. Keep it simple. All right. This is a very simple plane, the A200. But they're a lot better to drive now. Yep. Okay. Or why did you ask me then? Love your stream, mans. I learned so much about the game from just watching you. Right on, Goon. Yeah. Don't get me wrong. I'll be holding down the fort here with KSP 1 for some time. We got to get back into it. The whole fallout from Fallout. It's funny because I was playing Fallout, but the whole fallout from this thing is just reeks. It stinks. I've basically up until maybe this week, I've been pretty much avoiding KSP. KSP 2 getting knocked the way it did left kind of a big hole in my heart. You know what I mean? So it took me a while to kind of get back into it. I appreciate everybody's patience, but yeah, we'll get back more into KSP soon. Hey, Smitty. Sad to see you back on KSP 1. You seem to be the last player on KSP 2. Dude, I played that game as much as I could, man. Just yeah, sucks, dude. But whatever, we still got KSP 1, and now, because we don't have to worry about KSP 1 getting updated anytime soon, I'm kind of more open to putting mods on it. So, like Kerbal Wind Tunnel, which is pretty rad. Yeah, Ghostly, I'm sorry. I hate to be the bearer of bad news. Actually, with a little more engines, we could get this thing flying a lot higher. Fuel economics. This thing is the most fuel. So this gray line is the flight envelope. That is basically the point. All the parts of where the plane can fly, right? Like that the plane can do at 140 meters a second. We can fly at 10,000 meters. It's actually super good. That's really good. But we're not going very fast. And actually, that's the upper part of the flight envelope. That's not the most efficient spot. The most efficient spot for flying with this thing is 0.27 kilograms per 100 kilometers, right there. 7,200 at 230 is the most fuel efficient here. Yeah, Explorer, yeah. I started playing last week. I looked into mods and got overwhelmed very quickly. No idea what to get. If you're buying KSP 1 for the first time, Rebel, don't use mods. Understand the stock game and understand how to play it. There's enough here with the 2 DLCs to keep you occupied for a little while, and then find which mods you want based off of playing. Trust me, you don't need mods with KSP to have a good time. I've played modless KSP for a decade. No joke. And even then, I carry a very light mod load. Visual mods are fine though. Yeah, visual mods that don't screw with the gameplay, so like clouds, better environments, stuff like that. So max efficiency is a 460 meters a second. No, that's out of the flight envelope. It can't do that. The gray line is the flight envelope. Overlaid on the flight envelope is my fuel economy. This is showing where the engines are the most efficient. With my current setup right here, at 6,700 meters, going about 235 meters a second, the plane is the most fuel efficient. That doesn't necessarily mean the plane can't go higher. The highest altitude it can fly at is 10,000. But at 10,000, you're not making as much lift up there, so your engines have to do more of the work. Note that our level flight AOA is 13.6 degrees at 10,000, meaning the plane has to basically fly like this, and because the engines are pointed somewhat down, it has to rely on the engine thrust to stay flying straight. That's not very good. Yeah, that's not very good. Compare the angle of attack numbers to down here. Level flight is 5 degrees instead of 13. See what I'm talking about? This is actually pretty good. This is the A200's a pretty good little plane. Yeah, pretty good little airplane. I designed this for mission mode to do science and stuff. I even used my flag pack to give it a serial number. Yeah, we're a lot slower because the plane's basically flying like this. That's cool, man. Angle of attack curves. That's kind of cool, dude. You can use this to really find out the sweet spots for where planes can fly. That's cool, man. I didn't think this would just be a static readout. I thought like this would be a more interactive thing, like I'd be able to hit F12 and see. Oh. I don't know, W, and frankly, I really don't want to talk about it, man. Like, I don't want to talk about it. Like, I don't know if you guys picked up on this. When I said it kind of burned a hole in my heart, that means it's... Look, man, there's not a lot of things that I'm really touchy about. I'm touchy about that. I'm not gonna lie. I'm not gonna lie. I kind of took that whole thing personally. I know I shouldn't, but also... I know, Aqualex. I wanted to see for sure that's what was going on. I wanted little smoke lines going over the plane. Yeah, that would have been cool. I broke it. Yeah, we broke it. Let's try the K-79. My cargo plane. So how come this isn't showing the flight envelope? I mean, Chief, that has a lot to do with it, dude. I put, like, guys, I put my name on a product. I attached my brand to Kerbal 2. And I had some serious moral conundrums here when when what happened, because I put my name on this. I encouraged people to buy this. And I feel awful. Like, it really kind of haunts me a lot, because I'm the one that convinced, I convinced some people to buy this game, and, that's wasted money, because it was, you bought it on the premise of a promise, and that's what I mean about taking it personally, dude. Like, I got people to spend money on it because I thought they would follow through. I guess Take-Two didn't think so, but yeah, it happens, man. That's why, dudes. That's why it's still a sore spot. I really don't like putting my name and my brand on something and having it flop like that. That's really uncool. It's a disservice to you guys, and that's what pisses me off the most about it. The disservice to the community, myself, everybody. It's very upsetting. So I don't want to talk about it. I'm gonna get pissed off. Like, let's not do that. But here, yeah, let's see. Why isn't the flight envelope showing on this? There's no way you could have foreseen this outcome. I don't know, Eric. Maybe. Doesn't change what happened. Unlike other people, I'll take accountability for my actions. I think you need the main engines in stage 1. Oh yeah, the APU is in... Yeah, the APU is in stage 1, so let's try that. Update the vessel. Ah, there we go. Thank you. I forgive you. Yeah.
Discovery, go at throttle up.
Yeah, this thing... Here, let's see. Where is it the most fuel efficient? Guys, I'll be honest. This is super cool, but I'm not entirely sure this is going to help us with Dart. I mean, it might in some way, shape, or form, but it only goes up to 25,000 meters. This isn't going to tell us anything about the, level flight angle of attack. Ugh. I'd say this thing's happy place is right around 8,000. That's where I'd say it. You can expand the range. $8K, what is the real Earth altitude? What's the ratio? 10,000 meters a second is 33,000 feet. That's extremely high for Kerbal. You got to remember, Kerbal is 1/10 the size of Earth. So that's Earth, but it has Earth's atmosphere and it has Earth's gravitational pulls. That means Kerbin is like as dense as a neutron star, for what it's worth. Probably not a neutron star, but it's definitely a dense planet. A whole planet must be made out of titanium, which explains why the ground is so freaking hard. Water probably would not exist on a planet like this, but whatever. Journey 30,000 feet. 30,000 feet in KSP is like 100,000 feet. Yeah, that's pretty high up there. I haven't done like an exact calculation, dude, but because, yeah, I mean, if you can hit 30,000 feet, that's way up there. 33,000 feet in Kerbal is very high up off the ground. Like, that's... Like, let's just think about this for a second. The Kerman line, the Kármán line in KSP is 70 kilometers. In real life, it's 100 kilometers, right? So, if we're at 33,000 feet, hang on, let me check something. $231,000 feet is space in KSP. So if we divide that by 33,000, oh crap. So we're, yeah, okay, cool. Yeah, I mean, the metric could have told me that. I just wanted to be sure. So we're 1/7 of the way to space. Now, if we're at 33,000 feet and the Kármán line is 100, we are 1/10 of the way to space. So I would say times that number by 0.3, right? Or divide by 0.3, and that would pretty much get you your real life equivalent for the most part. I mean, that it's probably a little more complicated than that. So 33,000 feet times 0.3. No, divided. Sorry. Yeah. See, like I said before, dude, if you could fly 10,000 meters in Kerbal, that's like flying if you could fly 10,000 meters, that's 33,000 meters in real life. That's 100,000 feet, 110,000 feet. That would be your equivalent. You can get up here, that's like U2 territory. And right here shows something that's pretty interesting about KSP. The jet engines are ridiculously overpowered in KSP. That's not something we didn't know. The rocket engines are actually underpowered compared to their real-life counterparts. The jet engines are insane compared to their real-life counterparts. Bonana. At 70,001 in KSP, we're in a stable orbit. What's the lowest reasonably stable orbit around Earth? Most satellites and rockets go to a 120-kilometer circular parking orbit, Aldisar. Even that's only stable for a couple of days. An indefinitely stable orbit, so something that's not decaying, would be something above 600 kilometers on Earth. By that logic, right, the ISS is, if the ISS was in KSP, it'd be at like 65,000 meters. But the other thing to take into account is that Earth's atmosphere falls off on an exponential scale. So as you get higher and higher, it gets exponentially smaller, right? Kerbal's does that too, but at 70 meters, it doesn't just get exponentially smaller and smaller and smaller, it just caps. Kerbin's atmosphere would probably keep going past 120 kilometers, dude, but that would be the crappiest game mechanic. How are you going to simulate those decaying orbits on satellites? Felipe chose to abstract that a little bit to get the point across. So he took an element of realism out to make it so you could understand orbital mechanics better, because trying to manage all those satellites all at once would really suck, especially if everything's decaying. Or space stations, or capsules, or whatever. It would also make rendezvous nigh impossible. Not nigh impossible. It would make it tough to do it by hand. It wouldn't be impossible to do it. But there are real-life aerodynamic and orbital mechanic components that are abstracted in KSP on purpose for playability. Have you done a geo-orbit in Kerbal? Many times, Journey. Many times. 2863.3. I've made satellite constellations, dude. Oh, yeah. Should get back to doing that. Oh, you want to see something cool? we upped the conics one time, and because I was trying to show people what a rectilinear halo orbit looked like, or at least as close as you're going to get to it in KSP, and I ended up adding like infinite conics. What does that mean? It's plotting your trajectory out like 600 times through 600 sphere of influence changes, or SOI changes. So you know in Kerbal, when you go to the moon, you have enter moon's orbit, right? There's a SOI transition. Yeah. And then it shows kind of your trajectory around the moon. That's a conic. That's called a patched conic in KSP. And let's just say we got a little rowdy with the conics one time. Oh, I gotta find it. It's in here somewhere. Give me 1 second. There it is. Oops. That was not using a mod, no. Yeah, see, we had infinite patched conics. So a rectilinear halo orbit kind of goes out of the moon's SOI for a second and comes back. Like, it's very, very tight. And that basically is one of the things that keeps it in line of sight. Pretty cool, huh? Looks like Rainbow Road. I just thought that was super cool. See? Now, once again, the other thing about a rectilinear halo orbit is that it uses lunar precession to change its longitude of ascending node. That's how it always stays in line of sight. It uses the moon's unstable gravity to keep its orbit in line of sight of Earth. So you see how mine in this, and this is what you can't do in KSP, see how mine kind of loops over and loops over and loops over, and how it kind of is squiggling around like a helix right here? In real life, the orbital track would always, for a rectilinear halo orbit, would always be on that blue line. It wouldn't be looping out left and right and kind of doing a swirl around the moon. It would just be going like this. Like, your longitude of ascending node would always be perpendicular to line of sight of Earth. Yeah, it's actually, you know, we talked about all that nonsense with Gateway, and yeah, man, that did piss me off yesterday. But honestly, something like Gateway is pretty damn cool. It's a pretty cool anomaly in our orbital mechanics for our local system. It's neat. Not the worst idea to put a station there, but you gotta make sure it's not, you know, you gotta make sure it's not, you know, it can actually get there. That's kind of important. But yeah, super cool. Because there's no orbital perturbations from celestial bodies unless you get the Principia mod for KSP, see how it kind of swirls over? How it kind of looks like corkscrews? In real life, it wouldn't be a corkscrew. In real life, it would just be, it would look like a bowl almost. Just would be straight like that all the time. And see how it's straight right here? It would look like that all the way around in real life if you plotted the Gateway's track. Here. I can show you. Good questions, dude. Here's a video that was done by which university did it? Oh. Okay. This is from Johnson Space Center. So check this out. This is if you had an orbit that was kind of working around a Lagrangian point. Rectilinear halo orbits exist nearly stable behavior near the moon. See how that orbit changes? See how you're getting those swirls? The exact same thing that I was getting, but for a different reason. See that? That's what an NRHO orbit looks like. Now watch. This is really important. This is like, well, not really important. It's super cool. That's a DRO, a distant retrograde orbit around the moon. DROs are what were used during Apollo 1. They inserted Orion into an orbit like this. And what that distant retrograde orbit does is, because of the high, this is basically an overlaid highly eccentric orbit. What it would basically look like is a retrograde orbit with a very high apocynthion, or apoLun, the highest point in a lunar orbit. But when you overlay all the possible position, this is what happens if you like kaleidoscope the dang thing and you get your light envelope, like what we're seeing with the wind tunnel, but for all the positions that you could be in a DRO around the moon. That's why this looks like a crescent. I can talk faster than you can type, Aqualex. Deal with it! This all is really good. Yeah, here you go. These are all the different type of rectilinear halo orbits. There's a couple of different ones, but see how if you look at it from the side, it looks like a bowl? It looks like the profile of like a saucepan or something, right? There's a polar eccentric, they're polar eccentric orbits, right? So one of them has, you know, apocynthion above over the North Pole, and the other one has apocynthion over the South Pole, right? The NRHO one that we want Gateway to go in is the small one down there. Yeah. So that one that one doesn't really visualize it right. This one does. This is what it should look like. Check this out. See what I'm talking about? See the bowl? Now, notice that the orbit, if you look at a moon-centered inertial frame, look at how it's changing. Do you see how it's changing, the orbit's changing its longitude of ascending node? So it goes over the moon from, like if this is the moon right here, it goes over this way. And then the next time it encounters the moon, it goes over that way. And then the next time it encounters the moon, it goes over that way. That's because with a rectilinear halo orbit, you're staying in constant line of sight. Remember, the moon does spin. It does rotate because it's tidally locked. It just spins really slow to the point where it doesn't look like it's spinning from our perspective down here on the surface. But if you look at a moon-centered frame, this is a camera that's kind of centered on the moon. The orbit looks like it precesses around the moon. It changes its orbital parameters because of the moon's non-uniform gravitational pull. That's called lunar precession. And that's part of the reason why something like the Lunar Reconnaissance Orbiter has been up there for such a long time. We did talk about this yesterday. Orbits around the moon in real life, they do decay. If you left something in a 100-kilometer circular orbit around the moon, it'll crash it. The moon will pull it in. The moon's non-uniform gravity is a really tricky problem to solve. And that's part of the reason why Apollo didn't even bother building a space station. They just went right to the surface. They just said, no, we're good. Just go right down to the surface. And, you know, have the CSM loiter for, you know, a little while and then come back up and you're good. See? Also note that the orbit, each time it goes over the North Pole, is shifted slightly. Once again, that's due to precession. Isn't that cool? You can't do that in Kerbal unless you had Principia. Principia would allow you to do something like this, but Principia, if I had my way with that thing, it would fry my computer more than, I mean, I'm surprised that computer's still working, to be honest with you, but you get the idea. But see, we tried to do it, and we couldn't, because we couldn't use lunar precession to keep our orbit straight up and down relative to we couldn't keep our orbit perpendicular to the lunar equator, because there's no precession. So it just kind of moved around, and it made these squiggly lines over here. But it still looks cool. I'm not gonna lie to you. It still looks really neat. No, the flamer trench. Nice. No, it's not on purpose. I'm just making all the typos today, dude. Hey, Jim boy. G'day. I'll be a member of the flamer trench. I don't care. Doesn't bother me. Apollo be like, this looks like a bad neighborhood. Yep, lock the doors. Lock the capsule. Lunar gravity sucks. It's such a pain in the butt, dude. By the way, are we there yet? No! Damn it! So there isn't a stable orbit around the moon? No, there is Phil. A rectilinear halo orbit is stable. It's stable because instead of using the moon's non-uniform gravity, like if you just put something in low lunar, eventually it'll get sucked in. The non-uniform gravity will be used to deorbit you. A rectilinear halo orbit is called a lunar resonant orbit. Okay? So there's going to be some big words coming at you. Just bear with me. I'll explain it. The lunar resonant orbit uses those gravitational perturbations to actually keep your orbit stable. Yep. Cool, huh? It uses the moon's precession to keep it up there instead of having it works with the gravitational forces instead of trying to work against the grain. That is the exact reason why we floated the idea of Gateway in the first place. It's actually a pretty safe spot around the moon. It's a good place for continual habitation in lunar orbit. Now, yeah, that's technically correct. I honestly think that EML-1 is probably a better spot for a space station. Earth-Moon Lagrangian point 1. It's a neutral point in gravitational poles between the Earth and the Moon. It's about 5/6 of the distance to the Moon, because the Moon is a similar density than Earth, but it's 1/6 the size, it has 1/6 the gravity. So if you go 5/6 of the way out from Earth, between the Earth and the Moon, right? Earth's gravity, which is 5 times or 6 times the distance away as the Moon, they'll cancel each other out and you'll just float in what I call a gravitational tide pool. Like how something could get caught in a tide pool in a river, same idea. There's neutral points in gravitational pull. There's gravitational tide pools. I think that would be a much better spot for a space station, because from there, because you're actually stuck between the Earth and the Moon. The gravities are trying to pull you in both directions. All you need is a little bit of thruster work, what's called station keeping, to stay there, right? And the best part is that to get to that station, you don't need to circularize around the Moon, right? But anything that needs to go to the Moon does, right? So it's kind of a good neutral point, like a proverbial halfway point between the Earth and the Moon, right? You could use that as a great staging point for lunar exploration. You could use that to go into a rectilinear halo orbit if you really wanted to. I think that would be a much better spot for a more long-term outpost than rectilinear halo, but what do I know? I just play Kerbal, you know what I'm saying? You know what I'm saying? I just play KSP. Who knows? You cannot do that in KSP, Eric, unless you have a mod called Principia. Principia is a mod that has what's called n-body physics, meaning, so in real life, dude, everything has gravitational pull. You, me, your mom, Earth, all gravitational pull. Like, might be a little bit more than Earth. Sorry. I gotta chuckle out of it, all right? I gotta chuckle out of it. Shut up. So I derailed my own explanation. Anyway, so everything has gravitational pull. The thing is that what gravity is a warp in space and time, right? And gravity is kind of synonymous with density. So the more dense something is, like me, might have more gravitational pull, right? I did it again. So you have gravitational pull, I have gravitational pull, but it's getting completely gobsmacked and canceled out, basically, because Earth has way more than we do, right? So what I'm trying to tell you is that there's these things in space called orbital perturbations. Any perturbing force, anything that's going to perturb you, there's perturbing forces in space. Anything that has even a remotely consequential amount of gravitational pull is going to affect your orbit in space. Hear me out. We have a satellite that's like, take the ISS. Guess what? If the planets are rotating around the solar system and Jupiter comes close, it's going to pull the ISS a little bit in that direction. Jupiter's gravitational pull is so ridiculously strong, it'll pull the ISS towards it a little bit. It's not much, because we are a good deal away from Jupiter, but it will do that. Anytime you have a satellite orbiting around Earth, gets near the moon's going to pull it. Same exact reason why the tide goes in, tide goes out. You can't explain that. The Principia mod does this. somebody actually did this for KSP. They figured out n-body physics. So you could do rectilinear halo orbits. You could do cislunar depots. You could do that gravitational tide pool that I was telling you about. You could do all that, but the problem is, guess what? Everything you launch into space is going to get pulled in a different direction. If you tried to put something in a perfectly circular orbit, and you left it alone for a couple of days in game, it will not be in a circular orbit anymore. Principia mod when you grow up. Anyway, let's load up Dart. Let's get to what we set out to do today. Let's get 31 HL31 master design. Is that the one that I screwed with? That's wild. Thanks for the explanation. Dude, orbital mechanics is amazing. It's really, really interesting stuff. Well, I'll be a monkey's bare butt uncle. Look at that. Hey, that's not bad considering I winged. Damn it! I've been hanging around with Sawyer too much. I did all that from just messing with the wings and watching the relationship between the center of lift and center of mass. Dart is actually, its flight envelope is stable at 5 degrees positive angle of attack at 25,000 meters going 1,500 meters a second. That's not bad. That's pretty damn good for an eyeball job. That ain't bad at all. Oh my goodness. That's pretty good, dude. Cool. That's awesome. I'm not even mad. That's really neat. Let's check our L to D. Oh, wow. It gets really tight at around 12,500. Oh, wow. Super. Ooh. This gives you the avoid speeds and altitudes. For sure, dude. For sure. All right. Hold on. I gotta see something real quick, dudes. You know what I'm pulling up. You know. Rem, you got it. Blue, you were close. I gotta see it. I gotta see how close it is. I gotta see it. I'm sorry. This is actually super cool. I'm super hype on this. Block 1C orbiter. There we go. Well, what did I do? What the hell? Oh, I was like, wait, what did I do? There we go. Good. That's right. Yeah, that's great. That's a great flight envelope. That's perfect. That's exactly what I was trying to do. Oh, awesome. Dude, look at this thing. It works exactly how I wanted. This thing makes insane amounts of drag when you approach subsonic. Oh, that's so cool. Look, right when you get into the transonic regime, it flies like crap. That was on purpose, baby. Hey, I don't mean to toot my own horn, man, but beep freaking beep, dude. That's pretty good, man. That's pretty good for just throwing this thing together. And that just proves the panel tessellation is superior. That is the superior aeroshell for hypersonic reentry vehicles. Now, you guys want the X-33. All right. NG-21 pre-launch briefing going on, and I don't think a single question was asked about Cygnus yet. Who's on the panel, Phil? Is Steve there? If Steve and Ken are there, well, you know exactly where... Yep, all right. Who's on the panel? Bill Spetch, Megan Everett, Ryan Tinter, Jared Matter, Melody Lowe. Yeah, nobody. Yep. I'm sure they're having great fun answering questions about other people's screw-ups. Where is the SSTO? Okay. Let's do LV5A first. Let's get the small one. Oh, we should probably disconnect that. Actually really good. Collins V1, Corsi. We're on the 5th generation now. I think they just ended the briefing early. That flies better than the shuttle.
Well, we're gonna give her the old space try here. All right, guys, that sounds good.
That flies better than my shuttle. It has a better flight envelope. How? How? That thing is a Dorito. It's a Dorito with wings. How does that fly better than the... I don't know. I don't know. I don't know. All right. Now I got to check the big boy. Now I'm really curious. Hey, she's a nice lady. Shuttle's just, shuttle. Yeah, this is just built different comparatively to the shuttle. Dude, you can say whatever you want about the SSTO program during mission mode, but man, was I cooking. I made these vehicles without ever doing any flight validation. I made it by sight inside of the SPH because per my mission mode rules, you couldn't revert. So whatever test you chose to do really had to validate some results. So I spent a lot of time in the SPH sitting there tweaking this thing to get it aerodynamically right. Look at that. That's really good. Actually, I would say that's too good. I made it fly too freaking good. This thing flies excellent. And if you guys remember, the only thing I screwed up was a little bit of hierarchical placement on the landing gear. We were this close to getting that right. Ah! Grizzly Adams had a beard. Grizzly Adams did have a beard. That's, you know what? I'm proud of myself. Even though this thing blew up in my face and I lost like $2 million. I'm really proud of myself, man. Did a good job with that thing. It's a good piece of equipment. What do you mean it flew too good? I believe you, but what was the issue with that? Fundingo, I think we need to take some wings off. It flies too good. These vehicles, okay, so dudes, this is what drilled this into my head. The name of the game with KSP isn't building something that works. It's building something that does what you intend it to do. Now, generally, that's what works means, right? That's what that means, right? That's truth. Verdict. No, word that came over from little old England, all our ancestors. Damn. No, it's about understanding what you made. So I could have told you, based off of SSTO testing and based off of messing around with the wind tunnel, that it'll probably make it through reentry. And I was doing that by sight. If anything, I overestimated, which is still not ideal. Overestimation is okay, but your margin of overestimation depends on the construct of your systems engineering. It really depends on what you're trying to do. And once you achieve what you're trying to do, well, how good, what was your margins for achieving said goal? Understand? Like, it's, once you built it, you built it, you did your math, and now you got to fly the dang thing and you got to understand it, right? And once you get a full understanding of how the vehicle's performing, the closer that is to what your original estimate is good. It's good. You don't want to over-engineer it too much. You don't want to under-engineer it. Now, I'll be honest. I got this thing to work pretty damn well for what it is. I would say that I missed my margin by overestimation, but not by much. I didn't miss it by much, but I did miss it, which is pretty damn good considering I have no wind tunnel testing. I was not doing any of the math. What I was doing is sitting here with my center of lift, center of mass in the SPH for days doing this. See, if that doesn't look right, the reason why is because it's full of fuel. If I took all the fuel out, that would be perfect. That's actually super freaking cool that, I was sitting here and I kind of threw this thing together and I ended up overestimating just by a smidge, which is pretty awesome. That's what I mean by that flight envelope. This line is too low. It should, if I wanted to get these vehicles, and this is what I mean about understanding and intending to do something. These things in real life probably would have flown about as good as the space shuttle. So long story short, I could tell that this thing actually flies too good because my lower line of the flight envelope right here, the lower line of the flight envelope is just that, really low. That should be up here somewhere. Meaning this thing will just sail through reentry, no problem. You don't really need to be too incredibly accurate with it. You could just sail through reentry. You can kind of, this is kind of brute forcing down through reentry. The vehicle's so ridiculously big that it'll just absorb all the heat and it'll fly correctly. I think there's too many wings. I built too many wings into the fuselage. That's my overestimation. And because I built too many wings, that means this thing flies really, it can generate a lot of lift at higher altitudes at high speed. That's why this line is so low. And it would generate lift in a way that the actual Venture Star probably wouldn't have. And before you say, well, how do you know that, EJ? How do you know? Dude, I'm telling you, man, back in the day, we were cooking with this game. We were cooking. We were making 100% pure. No, what I would do is I would collect PDFs about this stuff. And one of these tells about one of these PDFs that I have in here. I don't know which one it is because it doesn't. Oh, here we go. Aerodynamic uncertainty. I used this one to basically figure out the flight envelope. This basically shows similar information to the wind tunnel. So, once again, the orbiter reference here, that's the space shuttle's re-entry, right? Re-entry trajectory. So you have, what's A? Alpha? Sorry, my brain just went potato. I have to go look that up. Angle of attack in degrees, yeah. I'm an idiot. I can't believe I blanked on that. I'm kind of ashamed. But then again, today's kind of cringe anyway. So these are the different aerodynamic shapes. The Cerulean, Michael 5, Maelstrom 5. These are the different re-entry profiles comparatively to the shuttle. Actually, that's... I mean, this is AOA, not altitude relative to Mach. But you know what? Give me 1 second. How come when I change this to, let's see, what happens when I change it to 50,000? Okay. Give me 1 second, dudes. Let me just close this for a moment. And what we have to do... Actually, I suppose it doesn't care about the landing gear. Now I'm curious about the wind tunnel calculations. Yeah, I know, Sam. It's kind of weird, right?
Discovery, go at throttle up.
Mother fricker, dude. I was close. I was close. I was close. I was real close. Dude, I was real close, man. We was cooking, man. We was cooking. Damn. Oh, that pisses me off. But I'm happy, but I'm really conflated right now. This is ridiculous. Oh, we were so close. It's 35 at Mach 10, son of a bitch. Oh. We were close, man. We were real close. Damn. It likes 35. So, check this out. Check this out. Above 30,000. So, we're going 1,500. 1,500 would be about, I don't know, 3/5 of the way to orbit. So, in real life, 3/5 of the way to orbit is somewhere around here. Like right in this area. Well, it's actually more like half. I mean, we need to go, man, it's 2,500. You can figure 23, right? So 1,500 is actually a little bit closer to halfway there, right? At halfway there, at 30,000 meters, so that's 100,000 feet, it's looking for 35 degrees angle of attack. Check this out. Halfway there, it's Mach 25 in real life, so that would be Mach 12.5. Look. 35 angle of attack. Funk! Damn it! We were bang on! Not much could be said about the rest of this, though. But we were pretty close. That was pretty close, man. That thing flies pretty close to the real thing. That's really cool to see. Dr. Death, I'm not gonna lie, that's a little bit of a confidence booster, considering most of the time here I was just kind of... It's like, I'm pretty sure that'll work. Now if I could just figure out how to get those freaking pads working, man, this would have been... Oh, this would have been amazing. Yeah, we'll talk about that on Flame Trench, Phil. Balls. All right. Well, with that being said, dump this. Before Flame Trench, let's get a re-entry test with Dart figured out. What was the problem with this project? I couldn't get the pad to reuse it, Reagan. The pad kept failing. This thing fully fueled is 2,500 tons. It was really hard getting stock parts to hold up 2,500 tons and then launch it. That was hard. I almost got it right. That sucks. That sucks because the pads are what held the SSDO program back, not the ship design. The ship design was actually pretty spot on. All right, let's check Dart. We should have kept going with the freedom architecture, dude. The problem is, yeah, Dart. I didn't get Dart right, Reagan. I screwed up. Yeah, we didn't get it done right. It was not a good re-entry vehicle. I pushed it in. It needed a lot more testing before I put people on it. And if I didn't rush it, because I was getting impatient, if I didn't rush it, I would have been fine. When we went to build Dart, I hadn't built a shuttle in a long time at the time, you know? And we never validated the landing. We never got the landing dialed in. We should have. We should have done more drop tests. Bigness. Nice, Nova. So where does this thing make the maximum amount of drag? So, drag force at 25,000, you will make the most amount of drag right there. Well, not the most, you'd make the most over here. Level flight AOA minus 49%. Interesting. Yeah, Rocket Guy, it's pretty good, dude. Dude, I'm not gonna lie to you. Like, without all this information, when I would design re-entry vehicles, I was shooting from the hip. But honestly, we went and looked at the shuttles, like glide slope and our SSTO's glide slope. They're pretty good. They're pretty good. Meaning, not that it flies really good. I built Collins to fly as badly as the space shuttle in real life, to use it as a teaching tool, and it's pretty spot on, dude. There's an aerodynamic uncertainty model PDF that I have in my VentureStar folder, and it has a little bit of information on reentry profiles from the shuttle, because it's using it as a datum reference about lift, you know, side slip, etc., etc. Where I'm comparing the models. Dude, it's pretty close. Especially for the SSTO. I got the SSTO pretty damn right. You know what, man? I'm pretty happy with myself. I'm not gonna lie. I'm not sure what that is, Tessa. Actually, if you know, it's funny, guys, you want to go back and look at when we were messing with this earlier in the week. I said that I really want this thing really needs to go through the lower parts of the atmosphere at about 10 degrees angle of attack. I did say that. That's more or less where I want it. But it needs to be like that through most of the... That's actually pretty good, man. Not bad. What is this thing's angle of attack for level flight? This would be level flight at 25 kilometers up. AOA for level flight at 25 kilometers, it requires a speed of 281 meters a second and an AOA of about 10. Oh, the sudden spike is the stall speed, yeah. I'm not sure, Nova. SpaceX tweet, and there's more below it. Is this about Cygnus? Because somebody just linked this a second ago, dude. Yeah, it is. Somebody beat you to it. Quick on the draw. What is that news? Saturday, August 3rd for Northrop Grumman's 21st commercial resupply mission. This is Cygnus, and they have pictures of it rolling out at Slick 40. Cool. Let's check LD. So 45,000. Let's check AOA. AOA at 45,000 here. Oh, it'll tell you your pitching torque. Fellas, I'm not gonna lie to you. I could very much design something and never have to test fly it. Yeah. Oh yeah. Oh yeah. I could just build something in here and do the wind tunnel testing, and I know it'll fly right. Want to bet Jeb's life on it? Yeah, sure. This time. Absolutely. Numbers don't lie. Would you say this mod is a bit of a game changer? Yes, I do. And more importantly, this could be used as a very, very, very big teaching tool. Whoa. Oh, this is great. Oh, Smoked, here's the thing. The reason why I'm confident isn't some type of crazy overconfidence. I have the numbers. Then, dude, here's the thing. Here's the thing. Numbers don't lie. Physics doesn't lie. It won't lie to you. There's no tricks. All right? I mean, don't get me wrong. You can get a curveball from time to time, but with good flight validation data, you're fine. You'll be fine. Like, this is something I had to figure out, and you'll have confidence in what you do if you've done the math. Like, okay, for instance, I'll give you an example. My 59, the truck, the Fred, when we built it, the red truck over there. It's a live shot of the garage. I got to finish that thing, but we'll get to it. We'll get to it. The truck. Okay? I have a shop manual for that truck. I redid all of the suspension, all the brakes. It's got 4 new leaf springs, 4 new bushings, everything. And I have the shop manual, and the shop manual tells me the torque spec. So I put it together just like the shop manual said, and I torqued every bolt to the proper specs. Dude, I'm sorry. The physics isn't going to lie. This engineering has already been validated from Ford 50 years ago. You're not going to screw up the engineering validation on a freaking leaf spring. The suspension on that 50s truck is simple. Dude, it's basically a tractor that looks like a pickup truck, right? The point that I'm trying to get at is that I know when I was driving that thing after Geek and I finished it for the wedding, I knew it wasn't going to break. I know it wasn't going to break. The reason why I knew it wasn't going to break is because we torqued the bolts. We torqued every bolt to exact specifications there. It's not going to break. It will not do that. Unless I do something with the truck it's not designed to do. Like, if I try to autocross the pickup truck, you're probably introducing failure modes there, right? But this logic can be applied to when you work on cars, and it's something it's really good to understand confidence here. I know the suspension on that truck is perfect. It is perfect. It's dialed. It's not going to change. I did the retorquing after a certain amount of miles, guys. For anybody that's a car guy, I did the torque. We did all the torque spec is right. I know for a fact because I have the torque wrench and the numbers behind me prescribed by the engineers that actually engineered the damn thing that it's going to work, and it works just fine. Suspension has never given me a problem, and guess what? It never will. That's what I mean, dude. The numbers don't lie. They don't. Unless you have a bad sensor, in which case, have fun with that fault tree analysis, because then the numbers are lying to you. But let's say in an engineering world where you can validate that your telemetry is legit, the numbers don't lie. They really don't. This is how SpaceX can seemingly figure out exactly what's wrong with a Falcon 9, even though the Falcon 9, like the Falcon 9 that blew up the other day, right? The second stage that failed. They knew exactly what was wrong. Did they get their hands on that second stage? No, it burned up in the atmosphere. So how did they do it? They had the data to prove it. Fortunately, they lost a line where a pressure transducer was. So that was probably pretty easy to figure out, that the pressure transducer should have a certain amount of pressure in it. It has no pressure in it. So something probably went wrong there, right? Did you slap it and say it's not going anywhere? You're damn right I did. I have mechanical wrenches, Slackster. I don't have a digital one. But once again, the tolerances on a car is good. A mechanical torque wrench is good enough. Looking at pitching torque on that graph with these AOA curves, should be a negative slope for stability. Should be able to see the curves for dry and wet center of mass. The numbers don't lie, dudes, and that's what I mean about having the confidence. I have no reason to believe this stuff isn't right. All this thing is doing basically a baked simulation of this vehicle at every different velocity and angle, right? I have no reason to believe these numbers are incorrect. I don't think the thing's lying to me, right? Why would it? The shuttle looked right from what, and that's from my validated flight testing data. Like, I've flown it a bunch of times. I can confirm that what this thing said is actually pretty correct. So here's the thing. I'm confident enough in being able to read these numbers and understand these numbers that I could build something and I know it's going to fly. In fact, I could contend to say that I could build something and figure out its flight envelope before we even do this. Like, and before people say, yeah, okay, we get it, you're good at this. I mean, yeah, dude, I have 15,000 hours in KSP. Of course I could, right? Like, if you had 15,000 hours in KSP, you guys probably do the same damn thing, right? I'm actually pretty damn confident. Now that I have the numbers to back up what I'm making, the numbers don't lie, dude. They don't. The only thing it does not know is part flex. Well, that's going to require a different type of testing, Tim. And what I've done, believe it or not, what I've done in the past is I've made vibration test stands to test for this exact thing. I get a rotor in game and I put an object on it, and then I start an object on one side, and then I start spinning it, and that introduces vibration into vehicles. I've made vibration test stands in KSP. Oh yeah. Oh yeah. Sebby, 96 months, tier 2, 96. Hello, and Kippy with a 30 months. Looking at the picture to the graph, should be a negative slope for stability. Should be able to see curves for dry and wet COM. All right. So AOA curves. What are you looking for? Bambadu, 9-month resub. Hey, been a while. Yeah, man. It's been a little bit. I hope your summer's going good. Dude, I'm actually gung-ho on this. This is fantastic. Oh, that's a great shot, dude. Did you see the news for the Nürburgring? Serious incident in the paddock. Pressurized air bottle exploded, sending multiple people to the hospital. That's not good. Show pitching torque there. Let me adjust the AOA because we have a re-entry vehicle here. Let's go minus 45. Actually, let's just go 0 to 45. Yep, negative slope means stable. Oh, rocket guy, dude, this is mint. This is so mint. I can use this to teach so much, dude. We can really take it to the next level. Thank you for the recommendation, dudes. This is actually super cool. And it doesn't... You can still tell it's the stock game, which is pretty cool. I can sit here and geek the frick out over these numbers. Numbers, chat. What do they mean? The numbers! Ooh. Rocket, what's with the funnies there? I don't know what these mean. Can you explain? Okay, so... Alright, Wolf, what we're looking at here is your pitching torque at different angles of... pitching torque relative to your angle of attack at 25 kilometers up. So let's. I'm just gonna do 10,000 here. I want to see something. Long story short, what Rocket Guy said, if this number's going down, you're nice and stable. If this number starts to go up, you're screwed. Why are you screwed? So what is pitching torque, right? Okay, so you have a control surface on an airplane, Wolf, right? Change altitude to say 1,000 and see what it looks like on a runway approach. Give me 1 second. Wolf, that's not good. That's not good. This thing is ridiculously unstable. So why? Okay, what's pitching torque? All right, you have a control surface on a plane. You pull back on the joystick, the thing tips up, right? That's going to deflect air up, right, and create torque to rotate your plane along its about its center of gravity, right? So you use an elevators to pitch up. The deflection of the elevator is going to create a certain amount of torque, right? If the line is going down, that means you can pull back on the stick and have complete control, okay? What that means is that at certain scenarios, my control surfaces are inadequate for controlling the vehicle, meaning that there's something on the vehicle that's going to basically overcome the torque of my control surfaces. It basically making us aerodynamically unstable. Like, long story short, if that line goes up, you're gonna crash. I have a lot of deflection on my control surfaces, Rocket Guy. I haven't seen anything. I haven't put this thing in any type of failure mode to suggest that you would a loss of control at lower altitudes. To be honest with you, dude. Like a stall? No, stall has not much to do with pitching torque. Pitching torque can induce a stall, Riz. So if you pull back on the stick and your control surfaces are all the way up and you keep going up, eventually you'll lose airspeed over the wings and stall. Pitching torque has to do with how much torque you have to be able to bring like the nose of the plane up, for instance. Hey, Tori, what's going on? Now, Rocket Guy, what I did end up doing is lowering the authority limiter on my pitch here. Let's see what that does. Is that, did it take that into account? No. Kerbal Wind Tunnel, it is a mod motor kid. Now that I just finished work and the sending invoices hopped in, I like that display. This is a new mod that I got. It's new to me. Kerbal Wind Tunnel. Yeah, I'm using it to validate Dart's flight regime, and then we're gonna go fly it. Basically figuring out where there are any potential funnies, you know what I mean? So break it down for us. What needs to change? Pilch, I'm gonna be honest, that is a little bit of a funny right there. Because I've never had any problems with loss of control. Yeah, never had any problems with loss of control here. This should be a static stability graph. The natural dynamics given, no input. So I would think you use that graph to figure out how much control surface you need to remain stable. Oh, okay. Yeah, okay. I misunderstood this a little bit. Who was I talking to about what this says? Wolf. Wolf, are you still here, buddy? This doesn't necessarily take into account control surface authority. This is just the vehicle flying around like this, where it's basically nice and stable with no input. Excuse me, I should have clarified, but that was because I kind of misunderstood it. This doesn't take into account you pulling back on the stick. That just explains what pitching torque is. But sometimes a vehicle can have natural pitching torque just because of the shape of a wing. I apologize. That was me. I screwed up there. But today is my day of screw up, so. Were you using RCS? I wouldn't be using RCS at this point in the flight. 10,000 at 100 meters a second? No. So you have 4 control surfaces. Say each one produces 1 kilonewton of force, and they are located 2 meters from the center of mass. You get 8 kilonewton meters of torque from your control surface. If your plot shows you have 7 kilonewton meters of pitching torque, you know you're good, as an example. Yeah. This is actually not a lot, dude. Max is 2 kilonewton meters, 2,000 kilonewton meters. That one control surface should be enough to, like. Actually, I'm kind of curious, dude. If I just set that to a deployed state, and we up. Yeah, there you go. Interesting. Interesting. Look at that. Static versus dynamic stability. Bingo, Kelly. Pitch input. Yeah, there you go. So Rocket Guy, correct me if I'm wrong here. If your pitch input line is always going this way, that means you're kind of good to go. You have enough control authority. But you could also extrapolate that by deploy angle relative to pitching to static pitching, not static pitching torque, but relative pitching torque, right? So you become statically neutral near the end where it goes horizontal. Interesting. It's not far. It's Kerbal Wind Tunnel, S-Master. Cool. All right. I saw what I wanted to see. We need Jeb. Yeber, where are you? Good. Save. Make sure this thing's got a full tank of gas, and then we're gonna just zip this thing up into space here. We'll edit it up into space because we're just testing. Make sure my launch escape system rockets are not in the same stage as my orbiter maneuvering system. We got to make sure that we have good monoprop on board. All the tanks are full. Those tanks are locked out. We can unlock them. Okay, cool. Save. So is this still good to go? I'd have to sit there and look at the data more, Pilch, but I do want to get this. I said I would get a re-entry test in. If we really wanted to be absolutely sure, I'd have to sit there and look at those numbers for a little while. But also, yeah. But yes, pitching torque you want to be negative, since that indicates an opposing moment relative to your aerodynamics caused moment. So it means that your nose is pitching up, your aircraft naturally wants to pitch up, and vice versa. Yeah, I got you. Natural positive pitching moment. Yeah, I understand. All right, so let's go set this to 700,000. Set orbit. Okay, Jebber is up in space. Let's just verify that all systems are working. I'm gonna put this on a trajectory that's familiar, the shuttle re-entry trajectory. If we did this right, it should fly on the same trajectory and it should be okay. We're going to activate our orbital maneuvering systems.
Robert Parker, are you there?
That's affirmative.
Okay.
Well, we're gonna give her the old space try here.
All right, guys, that sounds good.
Well, we're gonna try, Bob.
Nazlik, I'm good. How are you? Wait, show me how you yeeted him to space. That would be super useful for testing. Debug menu, Alt F12, cheats, set orbit. Set your SMA to 700,000 and get you into 100,000 orbit. Yep. You can also set other orbital parameters. Excellent for testing, dude. But as you can see, no other cheats are on. X out of that. You have a 10-second burn time. Node in T-minus 40. Turn the lights on. Make sure the suspension is right. No, this is actually just no, but this isn't improvements. This is just what the changes that we made on Wednesday or Tuesday. Okay, deorbit burn. Yeah, we had the wrong control point dialed in because I pitched the nose of this thing down a little ways. Gotta remember that. All right, let me just verify. Okay, we're good. Reorient the vehicle. Okay, before entry interface, we're going to set the drain. Dumping the remaining fuel. Okay, remaining fuel is dumped. I want to get rid of wheel authority. I don't want that. RCS and SAS are enabled. Control surfaces are on, but it's not a lot. Something is still providing wheel torque. I don't want any wheel authority to dart. All right, bring up the rates. Now, if we did this right, what we really want to look for is these. See these arrows right here? See the red? These are called rate indicators. All right. So this shows how much pitch you're inputting. This is pitching input, like what we saw, and that's roll and yaw input. We do not want those arrows maxing out one way or the other. if we do that, if it does that, that means it's no good. You don't want to do that. The reason why is because when you're going through re-entry, guys, reaction control systems shouldn't be used. Like, you shouldn't have to constantly fire a reaction control system to keep your vehicle stable. Your vehicle should stay stable via its natural pitching torque for a re-entry vehicle. Basically, see right here how we have little to no control input? The SAS is just kind of keeping us on an even keel. That's what you want. But the key is that you want this to stay like this through all of re-entry. That's a hard thing to do. Because think about it. The RCS, right in the name, reaction control system. That's your control system. That's not your stability system. Think about it, right? That's not your stability. You don't want to be using your RCS to keep the thing held in a certain position, right? Because then when you have to steer it, when you have to actually use your control systems to control the heading of the vehicle, if your pitch is already maxed out and you need to pitch up anymore, guess what? You're just going to nose into the ground. RCS should not be used to keep as a corrective measure. It shouldn't be used to trim out a hypersonic reentry vehicle. It should be used to steer a hypersonic reentry vehicle. Differences. See, look. See, that's no good. See right there? We're getting some slight negative pitching moment here. So where is this regime? This is 49,332 at 2294. Remember that. What we have here is failure to communicate. No, because we have to what we're doing here is actually pitching up. So that means the aerodynamics, the hypersonic aerodynamics are trying to force the nose down. That's not what we want. It's okay if see, it's correcting. The rates are going up and down. See how that number's going positive to negative to positive to negative? That's okay. But you don't want to be using the RCS to do that. That's no good. Actually, it isn't bad. Since you're a nose up, the aerodynamics are trying to stabilize you with nose down movement. We're too high up. Now, what happens if we bring some wheel authority into the fold here? See, the reason why this is no good is because you're gonna run out of monopropellant on the way down. That's an insane amount of. Here, let me try find control. It's no good, rocket guy. No good. This is not what we want. Look, see, now we're maxed out. Bad. If I let this thing go, what does it want to do? Bad. Now, don't get me wrong, we're aerodynamically stable. See how it leveled off? That's okay. It'll eventually stabilize. That would have killed us in real life. Like, we would be dead. 24 at 13.5 or 1350. That would have killed us right there if it didn't kill us before. Yeah, we got a little bit of flat spin here. Clouds. Covered. Okay, done. See you, buddy. Yeah, see? There's some pretty hard control problems with Dart here. That's no good. We gotta fix it. I didn't see anything weird there, Fia. It's just probably because it's an old game. Oh god, this is a repeat of what happened before. Hopefully my landing gear validation works. And the trees aren't collidable, guys, don't worry. Stupid hill. Oh boy. How did you fix the landing gear issue? I tilted my landing gear down, Rocket Guy, to take into account a positive 10 degrees angle of attack. So my landing gear are tilted down 10 degrees. So when I go to actually flare and land, my landing gear are straight down, perfectly parallel to the runway. That, with some spring, give it some spring and damper, they don't skitch out at all. Simultaneously, my front gear is tilted opposite. If the rear gear are tilted down, my front gear is tilted up because we're nose down. So basically when my gear contacts, at any point during landing when my gear contacts, the gear shape is perfectly parallel to the ground. If I'm recalling correctly, the wheel collider for the landing gear is actually a square. It's not a circle. So if you have a square collider on your landing gear, right, and you go to land this way and you land on a point of the square, the collider's gonna freak out, right? That's why the gear freaks out, I'm pretty sure. So I just tilted my gear. See, the gear is tilted down a little bit, and then my front gear is tilted up a little bit. So all the contact points, that square, it lands on the flat spot of the square, so to speak. Cool. Good testing. Yeah, it pretty much fixes it, dude, for the most part. Like, at least it's fixed it with Dart. Like, you saw that was an unprepared surface. I plopped it down. I slammed that thing into the ground because the ground started to come up. So I was starting to lose airspeed and the ground was starting to go uphill. So I needed to put that thing on the ground. So I brought the nose up to stall it and get it to fall onto the terrain well, it was relatively flat because we were starting to go uphill. We don't want to just crash into the ground. It's cranked to maximum, Rocket Guy. The other thing that I've figured out is, well, Kerbal doesn't have any compression physics, dude. You know how everything in real life is spring to some extent. Parts in KSP aren't springs. So if you bottom out your suspension, the gear freaks out. It starts to crack and drive. I just set friction to auto and set my spring rate to maximum. This thing has very stiff springs, so you never bottom out the suspension. Every physical system can be reduced to a spring damper system in real life. Yeah, Kerbal has no compression physics. Fun fact, guys, if you build a plane and you put it out on the runway and you see the landing gears start to move around, like skitch your plane to the side off the runway, that's Kerbal's way of telling you that you're crushing the landing gear and you need more of it. The more you know. Yeah, anybody ever had that happen? Or you put a rover out on Kerbin to try and drive around and the thing just kind of moves around, it kind of just skitches sideways. There's no compression physics in KSP. That's what happens in lieu of compression physics. Isn't that cool? Now, once again, we're gonna have to do a lot more testing with Dart here, dudes. I think our information can be found in the pitching torque with dry mass. Dry mass pitching torque. We were going 2485 at about 1354. Ha ha ha! Aha! Ha ha ha! Ha! Okay. Yeah, it was doing this. That's why it was going up and down. The thing was just going. Yowza. Yep. Yeah, wind tunnel is a mod, yeah. Oh, this is so freaking cool, dude. So Rocket Guy, let me make sure I got this correct, right? Make sure I'm honing in on this right. I was trying to hold that thing, right? You know, as we rotate around the planet, your angle of attack is going to increase relative to the horizon, right? I was trying to hold it till it got up above like 45. The second we got above... The second we got at basically 240, right? We started getting unstable. It was enough to, it's enough to basically want to zip down. Break time before flame trench. Yeah, I gotta go get ready, guys. I just want to make sure I'm understanding this right. Now, Rocket Guy, correct me if I'm wrong here. That line is going down, right? If that line was straight, does that mean we could just hold 45 just all the way down? Is that what am I looking at this right? So that is how you see your flight envelope. The plot shows that you should never exceed minus 18 AOA or plus 35 or you go unstable. I haven't really messed a lot with the part highlighting, Wolf. Thanks, Goat Meals. We're gonna dial this thing in next week. Guys, I'm gonna use Kerbal Wind Tunnel and I'm gonna redesign Dart a little bit more. That would be considered statically neutral, so basically yes, though that may not be what you want since you wouldn't want to be stable, yeah. Oh. Yeah. Rocket Guy, I think that line basically validates what we just saw, that my control systems are not adequate with these numbers. Pretty sure that's what I'm looking at there. Oh, this is mint. For sure, not at that high altitude. Dude. Guys, I think we just opened a can of worms. Now I see why I've been trying to get you to use this mod for years. Yeah, but Tessa, don't you understand that a blind squirrel finds a nut once? Broken clock is right twice a day. The vast majority of your recommendations have sucked. So how do I know? How do I know? But anyway, I'm just kidding. But not really. So yeah, that's yeah, we opened up a can of worms here, dudes. Yeah, now I want to eat the engineering. Taste the supplements of the engineering. I'll have to download and try it out tonight as well. Yeah, we opened up a can of worms here. Now I want to numbers everything because that's awesome. We're gonna dial in Dart and I'm gonna get it to work. Actually, dude, we could dial in anything. Pods, shuttles, Dart, any airplane. That's pretty complimentary to the game. I actually really like that. Tessa, I'm still not listening to your recommendations. Deal with it. No, seriously though, good call on that. That's really cool. If we could find a couple more mods like that are kind of supplementary, that would be super cool. Is KSP2 better than OG KSP? No. KSP is feature complete. KSP2 is not feature complete, and there's no sign that it would be anytime soon. Sorry. So, when Principia? No. All right. Guys, I got to get ready for Flame Trench. So here's what's going to happen. You don't need to go anywhere. Over on the YouTube side, though, because I want you to go watch the YouTube stream, I am going to shut down shop over there. But on the Twitch side of things, we still have a lot to do. We got Flame Trench, which is a podcast that I host with my buddies over at NASA Spaceflight, where we candidly talk about what's going on in the space program. You'd say the Flame Trench podcast gets a little spicy. Little spicy. Sadness, I'm just going to tell myself that we'll eventually have KSP2 with all the same features. Yep. Program, appreciate you. Thank you. So if you're on Twitch, you could just sit here. The podcast should be coming up at the top of the hour. I have about 20 minutes. I got to go over there and get ready. And then after that, I am going to do Friday Night Racing. Maybe a little gaming session in between. Maybe we mess with Kerbal a little more before racing. It really depends. We'll see. Anyway, but still got plenty of stream left on this Friday in the middle of summer. It is absurdly freaking hot in this room right now. Kerbal makes the computers warm. Help. 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 You get a little spicy. No. Now I made it weird, hey? Boy, Mike. Help. Anyway, if you're gonna watch the Flame Trench and you're over on the YouTube side of things, I'm gonna shut up shop there. I'll post the link to it in chat somewhere. And then on the Twitch side, don't go anywhere. It should be about a 20-minute just intermission here. So yeah, plenty more. I'll be back, and I'll see you on the Flame Trench. Thank you very much for watching. Guys, yeah. Oh, by the way, all Kerbal all next week. Yeah. This opened up a can of worms. Yeah, this is not good. This is the same feeling that I felt when we first played Workers and I realized how awesome of a game it is. I ended up playing it for the next, 3 months straight. So, just thought I'd let you know. Not good. Not great, Bob. Well, it's good for you guys. I mean... whatever. Yeah. New can of worms is open. Can you imagine this thing with KRPC? Yeah. Oh, yeah. All right. I'll see you guys in a little bit on Flame Trench. I'm going to, get a little rowdy. Yeah. Okay. Anyway, I will be back in about 20 minutes. Stand by for acquisition of signal from NASA Spaceflight.
Who has come?
Starline
Who?
here.
EJ Saw. What's that? We missed you.
I need another
I did.
Jan Michael Vincent.
You sent me, yes. EJ, what do you want your background to be? Gateway. That's what it should be. Yes. I think that's Gateway. Is that Gateway or is that?
Kevin's about to put a picture of the ISS and say it's Gateway.
I think I am.
Gateway's in trouble, crabs are invading Starbase, and Starliner is still in space. On this week's Flame Trench.
And here we go. We have liftoff. Propulsion continues to be normal.
R68 chamber pressure looks good.
Following up. Roger, roger, planet.
Water towers, fly! Yes!
Tango down to nominal.
Flighting down to SC off. Bring in SC off.
It's orange!
Oh my god! Oh my god!
Decollage.
Put that in the big bag, Jingle.
343 unfolds to go. Indeed.
We rise together, back to the moon and beyond.
This methane will be igniting the flare, correct?
Yikes. You dead? Sure. We don't need any more of these.
Welcome to this week's Flame Trench, NSF's weekly informal news show. If you want the straight news, you can watch Twist, which we released earlier today, but this is where we get a little spicy, hence the name Flame Trench. I'm Jack Byer for NSF. Welcome. I see the 5x5s in chat. Thank you, chat, for letting me know we're coming through loud and clear. As always, though, we have our clever cohort of co-hosts starting off this week with EJ. EJ, what you reading this week, buddy?
Hey, I got Rocket Ranch. Rocket Ranch.
Nice.
It's basically an encyclopedia on integration hardware for the Apollo program.
Nice.
10 out of 10 would recommend.
I feel like we might need a book circle with EJ. Also, nice hat, by the way.
Thank you.
Quality Cygnus hat.
Cygnus hat. Yep.
Well, also joining us this week is Trevor. Trevor, do you have a book or a funny hat?
I do not have a book nor a hat, but I am here this week, so we got some good things to talk about, and then some also less exciting things to talk about, like news we don't want to share, but we'll get there.
I mean, you can't pick and choose your news. Sometimes the week has some disappointing things in it, as we will get into. Chat, if you have any questions as we go through today's episode, at NASA Spaceflight in chat, and we'll see your question pop up in some software we have running in the background. And also, I don't know if we have him right now. We have the disembodied voice of Ryan, which we'll be talking to when we get to Starship. Ryan, are you there? Say hi. He's not there. All right. Let's get into it. Lunar Gateway, huh? It's overweight. And the Gao report that came out is pretty damning. I don't even know where to start. EJ, I guess I'll just let you. Basically right now, picture in your mind, Lunar Gateway is Indiana Jones, and EJ is the boulder rolling towards Indiana Jones. So let's.
Jack, give me the idol. Give me the whip.
Let us have it, EJ. What's going on with Lunar Gateway?
All right. Well, there was a GAO report. GAO stands for the Government Accountability Office. All right. The Government Accountability Office released a report regarding the power and propulsion element and the habitation and logistics outpost, the first two modules for NASA's Lunar Gateway. So, first and foremost, I'm sorry, but my camera is not the best today. I had a little bit of hardware issues here, and I'm still trying to work the kinks out. You'll just have to take VHF, EJ, and adjust the rabbit ears. You know what I'm saying? So
yeah,
that's what's
it's
going.
Fine. We'll pretend
adjust your
watching you on the old standard def TV. Yeah.
Do you believe in miracles? Anyway, all right. Sorry. So this GAO report had some interesting things. The two biggest things are, well, actually, the biggest thing is what's called co-manifested vehicle mass, or CMV. The CMV is basically the combined mass of the power and propulsion element and Halo, because originally these two modules were supposed to launch in SLS's cargo carrier on an SLS Block 1B, and Orion would put it out there and send it. And a little while back, NASA figured out that their SLS's contract structuring does not really permit, the way it's kind of set up doesn't really, they couldn't make the SLS cores for this on any usable schedule. So the decision was made a little while back to move the power and propulsion element and the halo into, make them one payload and launch them on a Falcon Heavy. And that's where this GAO co-manifested vehicle mass thing comes into play here. Long story short, they're both way too heavy. It's too high in mass, because weight has nothing to do with it. We're talking about space flight. It's not great. It's not great. There's,
yeah, I mean, it's a fairly big change to go from two separate things to one thing on one launch, co-manifested.
Yeah, that is the least of the problems here, Jack. Yeah, that's the least of our issues. So let's start with the power and propulsion element. So the PPE is more or less working okay. It has a little bit of what's called a negative mass margin. Negative mass margin is a nice way of saying it's too heavy.
Right.
That's why we're talking about CMV, co-manifested vehicle mass. So, because now, once again, you're not launching PPE by itself, you're not launching Halo by itself. They chose to combine them together. And when you combine them together and put them on a smaller rocket, Falcon Heavy, even though you're saving costs, it's making a more complicated vehicle. Now, that's not necessarily what's wrong with the power and propulsion element. The power and propulsion element's thrusters are not adequate enough to be able to station keep the gateway when Starship is attached to it.
Oh my god.
Yeah, the thrusters are inadequate. Yeah, that's not great.
If you saw Twist this week, there was a graphic of a Starship docked to Gateway, and it's comical to say the least.
Yeah.
Well, just on that specific element alone, you've played way more Kerbal than me. You're way smarter than me when it comes to orbital mechanics, just from that alone, plus everything that you've read. Mr. calling you Mr. Book, but couldn't Starship just do the station keeping? Is that it? Like in that scenario, what would prohibit that, or would you have to like make the docking adapter like way more robust and thus more massy? I don't know. There's the graphic in our back channel.
That's a fair question to ask. So the big thing here is that, yeah, sure, of course you could do that. Now, what do Starship's HLS's thrusters look like?
Good question.
What's its RCS
Good
look
question.
like? Is it Dragon derived? Is it based off of a boil out of a shelf life commodity, like a propellant? Like if they're using hot gas thrusters or something, it could boil off. Now you got a big problem because you could use too much. Is it using tank ullage, right? Like what does Starship HLS's thruster system look like? I mean, maybe they could lift Dragon thrusters and do that, like what they did with the ISS deorbit module, which just has 43 Dracos just shoehorned on the back. Speaking of Kerbal designs,
I love that thing.
I know, it's ridiculous, right? What does the system look like? And the long story short, Jack, is yeah, sure, of course you could, but that is going to require another layer of systems engineering to get those two vehicles to talk to each other right.
Right.
Part of good systems engineering and design is making sure stuff like that is figured out. Now, I don't think that's necessarily a mark against the people working on the power and propulsion element or NASA in general, considering when the PPE came on the books, we had no lander. So they didn't know what the lander was going to look like.
Right.
They didn't realize it was going to be this freaking tank of a vehicle, right?
Yeah.
Connected to it. So, guys, if you're looking at this picture here on my right, your left, the thing with the solar panels on the very back has solar electric propulsion. There are ion thrusters. And what they do is they basically flow inert gas through a combustion chamber, and they arc electricity through said combustion chamber utilizing the Hall effect that creates ionized it ionizes the gas, and the resulting ions create a little bit of thrust. Now, those ion thrusters on the power and propulsion element are off-the-shelf thrusters that are derived from a geostationary satellite. I believe it's a sat bus that's used for, geostationary communication satellite. I forget which one. I know chat will let me know. So those thrusters are, you see, they're those little tiny nubs on the very end of the module in the far left with the solar panels on it. And then you have this this thing right,
Right.
here.
Right.
So the thrusters aren't adequate enough to be able to station keep. Now, all right, sorry, I'm trying to cover this stuff quick. Now, in a rectilinear halo orbit, that is a type of lunar orbit that is relatively resonantly stable. So what does that mean? EJ's using the big words again.
All I know is I hate rectilinear halo orbit. I hate
Why?
it. I think it's the stupidest orbit. Oh, you want to
Super
come
cool.
home? You're gonna have to wait 2 weeks.
Oh yeah, no, not a fan of that. So
amongst other things, but please continue.
It seemed like such a random requirement to add from the start.
So-
Like it seemed like them choosing that orbit really kind of sabotaged the rest of the program.
yeah,
It's
Trevor,
not great.
Dude, I'm kind of with you guys on that one. I'll bring us back in. Just
All right, go.
Let me Alex explain you. Sorry,
him
Alex,
cook.
I love you, man. All right, so okay, so this type of rectilinear halo orbit, one big benefit is that it's maintained line of sight to Earth all the time. You don't have it transiting the far side of the moon, so you're in constant communications. So it can be used as a relay for the surface. That's a big deal. If you looked at it just around the moon, it is an eccentric polar orbit with about a 90-degree inclination. Now, what does that mean in plain English? It's really close to the North Pole of the moon and really far away from the South Pole of the moon when it's at its highest point. The reason why is because you're going to be able to maintain radio communications with a base on the South Pole, where NASA wants to go. It's actually not an incredibly bad idea. It's a good place for a relay. It's a good place for a relay. It's a good place to kind of park a station. And what I was getting into is that it's resonant stable. So not a lot of people know. If you're a Kerbal player, you've never experienced this unless you have Principia, right? The Principia mod's crazy, by the way. There are decaying orbits on the moon. The moon does have a small atmosphere, first and foremost, so you're subject to, I would say aerodynamic perturbations, but the aerodynamic perturbations are charged particles that are kind of trapped on the moon. It's not like you can go up there and take your helmet off and be like,
Right.
Not a good idea. Would not recommend. But also, the moon is, because so many things have hit the dang thing, especially on the close side, right? It's more dense on this, like me, it's more dense towards the Earth-facing side. That's why you have those gray lunar basaltic regions, right? The gray spots, right? Where a lot of the Apollo missions landed. That side of the moon, the side that's facing us, is actually denser than the far side of the moon. So what does all that mean in plain English? The moon's gravitational pull is not very uniform, and there are very high deltas in a wide range of gravitational pull in different areas around the moon, because
from the Apollo days, the mass concentrations that they had to worry about.
Yep.
Mass cons.
Mass cons, that's where we learned it from. So Gateway, instead of like having something like Apollo where you're working against the grain, where they had to station keep against these gravitational perturbations, right? The Gateway actually utilizes it to change its longitude of ascending node to always be in constant sight. Basically, the radial axis, the radial component of Gateway's orbit is always facing towards Earth, which maintains constant line of sight. And the orbit is stable. It's a stable orbit. It only requires, and why do I bring all this up? It only requires about 10 meters a second station keeping every once in a while, and that's from one of my rocket science buddies that told me that. Rocket guy, you're the man. It doesn't require a lot of thrust to change, to keep in that type of orbit. Now, don't get me wrong. There's nothing as like indefinitely resonant stable orbits. There's always orbital perturbing forces that cannot be predicted. Like what if Jupiter is near you, it's going to pull it in that direction. Or if, Mars is, flying by, when they're orbiting around the solar system, it's closer, it's going to pull you in, the infinitesimally small meters a second in one way or the other. Right. So you're always going to have to do a bit of station keeping. This is mostly resonant, but you only require about a 10 meters a second delta V window here to change it. But that's the thing. Those electric propulsion thrusters on Gateway, and 10 meters a second doesn't seem like much for a Kerbal player, right? That doesn't seem like a lot. Any Kerbal player is like, 10 meters a second, no big deal. I think there's a fan behind me, like a small fan behind me that's pushing air around in my office that makes more thrust than one of those thrusters. So solar electric propulsion is great, but I'm pretty sure if you did that, that's more thrust than one of those things. So long story short,
super efficient, but very low thrust.
Bingo. Yeah, exactly. So long story short, those thrusters aren't adequate to move something like HLS around. That's the problem with the PPE. That can be forgiven. I would say, like, that's not that big of a fix, but putting bigger thrusters on it means that you're sacrificing something else. It's always a freaking trade-off, right? Especially when you're sending stuff out to the moon. A bigger rocket would be adequate with a useful upper stage, but, we'll get to that later.
We can't have those because we can't have nice things, but please continue.
Exactly. Now, the second part is the Halo module, the Habitation and Logistics Outpost. This is where this gets bad. The Habitation and Logistics Outposts, when they were for whatever reason, when they were doing their systems engineering on mass margins of components, which is something that should be tracked throughout the entire development of the program, right?
Right.
If somebody's like, oh, this needs an extra light bulb, it's like, okay, add like a couple grams here and there. And the mass margins, right? The mass of each component should be tracked as you develop more of it and you start making stuff. With that being said, they just forgot to take into account the wiring, all of the wiring on the Halo module, about 600 kilograms worth of wiring. They just forgot to add that to the final mass tally, which is why we have negative mass margin on our co-manifested vehicle mass.
What's just mind-blowing? Like, how could that possibly be omitted from the calculations until you get to a point where you're like, oh wait, well,
dude, you could do a Michael Bolton, screw up some mundane detail here and there. Like, I get it. There's a lot of things involved, a lot of hands touch this. There's a lot of people involved when you have such a heavily spread to the winds program. Like, if somebody's making the Halo module, somebody's making this, somebody's making that. It'll launch on Falcon Heavy. NASA's overseeing the whole thing. There's a lot of fingers in the pie here. It is easy to make a mistake like this. However, at this point in development on the Halo module, missing a 1,500-pound mass margin is unacceptable. I'm sorry, that's really telling. That shows just frankly awful systems engineering. That's really bad. That is really bad. That would be like, I have a car and the car should have 4 tires, but I only have 3, and I'm going to drive it to the supermarket and it'll work just fine.
Right. Oh,
yeah,
God.
that's a glaring issue. That's really bad. Big red flag. Now, are these problems fixable? Yeah, sure. I mean, NASA in the GEO report went on to say it's like, oh, okay, we'll just basically take these components off. Now, that's also part of good systems engineering. You kind of take that into account. There might be items that are high risk for mass, right? There might be items that are high risk. And, if so, have a contingency plan, be like, okay, this is a component that absolutely needs to be there, like wiring. Maybe you don't need that air conditioner. You know what I mean? Maybe you don't need all the bells and whistles here, right? Like, actually, they do need an air conditioner. You need to breathe. That's important. But that's just an example. So maybe you don't need the racing stripes. So they have contingency. It adds horsepower. So
I mean, hey, it does make it go faster, but that paint does add mass.
So basically, all this stuff coming together basically means that the power and propulsion element and the Halo module combined together are too heavy, even for something crazy like Falcon Heavy to be able to loft this thing into rectilinear Halo orbit. Falcon Heavy can't put it on a proper translunar injection trajectory. Falcon Heavy, and then the gateway thrusters would have a hard time circularizing with the types of mass. Now, once again, this can be fixed. It can be fixed. In development, you're always going to have curveballs, right? I mean, forgetting the wiring is pretty messed up. That's bad.
Forgetting the wiring does it like reminds me of a Proton rocket where they installed the accelerometer upside down, or the Delta II where they didn't do the unit conversion, or the NOAA satellite where they didn't strap it down to the mount while they were doing the turnover in processing, and it just fell off the mount onto the ground. Like,
so bad, dude.
It's one of those things that I laugh, but like, what else can you do? Because spaceflight is incredibly hard and complicated, and when you see something that you would think would be easy, like, this is literal rocket science. Like, how are we just forgetting the mass of the wires?
Now,
but EJ, we do have a question from Joe.
Okay.
Saying, why not separate the 2 payloads and just launch them on 2 Falcon Heavies if Falcon Heavy can't launch the co-manifested vehicle?
Halo has no thrusters on it.
Crap.
Yeah. That's a big problem because you got to remember, guys, these payloads were designed to launch on SLS in the aft cargo carrier or the universal stage adapter, not aft cargo carrier. That's a shuttle thing. A good thing that they should have done, frankly, to be honest with you. But that's a whole rant for a shuttle Sunday if I ever get on that one day.
Oh, you should.
Yeah, that'd be fun. So the universal stage adapter on SLS Block 1B, Orion was designed to move these components into place. So that the idea is that Orion basically works as your space tug. It'll assemble a station for you until they get an arm out there in which you can support berthing and building the station, like just what they do with the ISS, right?
Yep.
Halo module wasn't designed for that. That's why, and it's funny because, you know, when they first thought of this, they were like, yeah, we'll maybe launch it on SLS. And for whatever reason, as far as I can tell, didn't bother telling the SLS people that they want to launch this on SLS. It's the same thing with Europa Clipper. They put Europa Clipper, you know, the program got funded, the probe got funded, and they're like, yeah, we'll launch it on SLS. And then the SLS people were like, wait, what? Really? wait, what? That was the reason why that moved to Falcon Heavy as well. But
Hey, hey Teddy, we got any spare SLSs in the warehouse? Nah.
Nah, don't have any of those. Right? So
It really seems like in general, a lot of the all of the payloads that were at some point planned to launch on SLS. It seems like there's no communication or expectation about how many or what the production rate of SLS was going to be. Because when you're making barely one a year, like it makes zero sense to launch a payload on it. It's just it was a weird miscommunication for sure.
It's just like a lot of different payload providers figured SLS would be there without actually checking to see if it would be there.
Bingo, dude. That's exactly where I was going with this. This, you know, you could say, oh, it's the Halo people, or it's NASA not holding their contractors accountable, or it's the contractors not being held accountable. You could point the finger a lot of places. The real glaring issue here is that we thought it would be somehow a good idea to design a vehicle that maybe goes back to the moon or maybe goes back to Mars, right? There's no integrated architecture here. Like to this day, what is SLS supposed to do, right? And don't get me wrong, that's not a knock against SLS. I think SLS is a pretty good design with the Block 1B and the exploration upper stage. I think it's good. I'd say seriously, dude, it's a capable vehicle. And ironically, it isn't the bottleneck anymore, which is really funny. Everything else seems to be.
Are you thinking it's like more of a failure of vision or like a lack of vision kind of thing, or?
Yeah, dude. I mean, let's use an airplane analogy this time, dude. You don't design an airframe you don't go to design an airplane, right? And be like, you know what, this engine or this plane might have two engines later. I'll design it with one, but we really want two. And then you get it to fly with one engine, right? And then you add another one later. That's not how systems engineering works for aerospace engineering. You don't do interims. You don't do stopgaps. And if you do, you best be having a good roadmap to overcome that, because guess what? You know, a lot of people say the best fix, the most permanent fix is a temporary fix, right? And that logic especially applies to spaceflight. The interim cryogenic propulsion stage for SLS, you know, we chose to do that. We chose to use something off the shelf, you know, because it was cheaper. But
it's interim. It's just interim. Don't worry about it. We'll change it to something else later.
Yeah, exactly. So you're going to change it to something else later. I mean, I guess you can do that, but why? How is that going to save you money? You're going to have to re-baseline the vehicle with a new upper stage. I mean, which is what NASA has to do. Like, this is what I mean. Like, there's no integrated architecture. SLS had no clear stated goal. And until the Artemis program itself came around in 2018, 2019, we really weren't sure what the thing was going to do. And this gets into two major points. And this is where this gets a little spicy, okay? Jack, you're right. There's no integrated freaking vision here. Like, what are you guys doing? I don't think can you tell me what NASA's doing right now? And dude,
going to the moon and beyond.
Yeah. What does that even mean? That's just word salad. You just said some words, right? Like this is where they're gonna get a little spicy, man.
Going to the moon sustainably on the least sustainable architecture imaginable.
Yeah, it's absurd, right? Like this is ridiculous. Like you know, you hear people at NASA have the gall to say that Apollo was somehow not as sustainable. Yeah, guess what? Whatever your abstract goals are with SLS and Artemis, the Saturn V, the LEM, and the CSM could do it easily. Could the Saturn V build Gateway? Oh, yeah. Yeah, absolutely. And it probably would be better at it. So don't give me this, Apollo.
Can you imagine a Halo module that's made of a Saturn upper stage like Skylab was?
It'd be killer, man.
Massive.
Awesome.
All this room for activities.
Yeah, so yeah, exactly. This is what I mean. Like, you have the gall to say that, and then you can't even tell me what are you going to do with this? So the other thing to take into account, with this gateway stuff and this co-manifested vehicle mass, is that this Falcon Heavy needs to be ready to go, ready to launch 3 months before Artemis 4, which means that SpaceX and the two commercial contractors for the PP and the Halo have to basically have all their T's crossed and I's dotted, and the vehicle basically teed up and ready to go 3 months before Artemis 4. So Gateway has the time to get out there so Artemis 4 can get to it.
Right.
When is Artemis 4 launching? Anyone? NASA doesn't even know. That's the other part of that GAO report. We're going to assess when this thing needs to be launched, and we're going to figure it out. That's that. Yeah, there you go. Guys, this is ridiculous. The big overarching problem here is that there's not really any accountability. There's no accountability here. Don't get me wrong. This isn't a knock against SLS. I think SLS is a good rocket. My only criticism is that it needs to launch more, because expediency is key here. The only way to keep a government program accountable and in line, historically speaking here, is to have a deadline, have a clearly stated goal. If you look at like the Apollo program, I don't know, that's a pretty good example. Right, get to the moon before the 1970, and B, as a kind of a undertone, wasn't explicitly mentioned, but by President Kennedy, but an undertone was beat the Russians there. To serve, to organize, and measure the best of our skills. Right, that was the clearly stated goal. You could even look at other projects with clearly stated goals. Look at the Manhattan Project. Oppenheimer came out a little while ago. A lot of people are interested in that kind of stuff. There's a clearly stated goal: make nuke before Germany does. Done. There you go. Right, there's clearly stated goals here,
right,
and that's what you need to keep these programs going. Without any goals, without any deadlines, without any integrated architecture to accomplish said goal, we're just kind of scattered to the winds. And that's, frankly, guys, like this is the part that's going to get spicy. And maybe I shouldn't say this, and I say this out of love because I love NASA. Everybody here does. We're all here because NASA's a beacon for space exploration. It should be on the cutting edge of stuff. And this program is just scattered to the winds. It's ridiculous. And all that does is create infighting and makes every single program want to grasp for, funding and cancel another program just to make sure that they have the funding to get their program done. That creates infighting in NASA. That's terrible. NASA is compartmentalized like that on purpose to get the whole system to work together. And what we've done here is we've created a scenario where it does the opposite of that. Why do you think Viper just magically went on the chopping block? The biggest thing was they were worried about funding overlap with other missions, which means there's infighting for funding. Same thing with Chandra. Same thing with Mars sample return. Same thing with canceling the XEMU program. This needs to stop. This is unacceptable. We should not be cool with this. It's terrible. It's unacceptable. And I think it's a symptom of a much bigger thing. There's no overarching goal. There's no vision, Jack, like just what you said.
Yeah, I mean, I appreciate how spicy you are about this because
it's annoying.
You're sustaining me right now. So thank you.
Yeah.
I don't really have anything to say or add other than it's disappointing. You would hope that NASA could end this sort of infighting between their programs.
Well, the only way to do that, dude, is to have an overarching program. NASA needs a goal. Not we might go to the moon soon or we might go to Mars soon.
All right, so if you are NASA Senator, Administrator, Astronaut Bill Nelson, and you are going to, give NASA a vision. What vision do you give them? I'm gonna make Trevor go first. Like, if you could snap your fingers tomorrow, Trevor, and shuffle this all around, what would you do?
I think I think one thing that NASA has been very clear with the success of commercial crew and commercial cargo and whatnot is that NASA really just, like, day one, they need to get out of rockets in general. That is not what they are good at this point. They're terrible at it compared to the commercial entities. And they really need to focus on, in my opinion, the science missions where, NASA has been having win after win after win with Perseverance, James Webb, Euclid, all of the massive telescopes that they've and other science missions they've launched recently. I think that definitely makes a little bit more sense. And then from the exploration side of things, I feel like borderline NASA seems not needed for going back to the moon between Blue Origin and SpaceX and all of the commercial suit development and whatnot. Like, obviously there are large subsidies, but it seems very possible that that could be done, to some extent commercially, if not have everything on a fixed price contract, and then just leave them to working on the bigger problems like going to Mars or whatever. I think that really needs to be the clear objective, since that's something that we don't know what problems we're going to have to solve to go to Mars yet, when we have a very good idea of what problems need to be solved to go to the moon.
All right, guys, I have a question because
What?
like EJ, this is
this?
God. This is God. I'm over here in Connecticut. So EJ's talking about the fact that NASA isn't controlling things, right? And it's almost like the left hand isn't talking to the right hand, and the right hand isn't talking to the foot, right? So it seems like this seems to be a situation where one company has built one thing and never told the other company that. And I'm making a hypothetical, right? Never told the other company that they were doing that. So now there's a problem. And then Trevor, on the other hand, is saying, well, NASA needs to just get out of building rockets. But isn't the problem that there's no project manager? Like, no one, there is no single vision. Like EJ said, there's no one project managing the Artemis program.
There's no goal. I mean, Trev, I definitely can see the argument for saying, like, oh, NASA, they just get out of the rocket industry. This is ridiculous. But you cited a lot of awesome JPL projects, dude. Well, I mean, people have a short memory, guys. There was a time where JPL was in the same position in the early 80s. JPL couldn't make anything freaking work. It seems like they couldn't get anything done. And what fixed that whole thing was some accountability going in there and basically cracking the whip to make sure they got stuff done, right? And look at what JPL is now. I refuse to believe that it can't be fixed. I think that NASA jumping ship off designing rockets is notoriously short-sighted. Not necessarily because they need to be making rockets. I mean, personally, I think if SpaceX can land a rocket, NASA should have an in-house thing that can do the same thing. I believe in having parity there. That's the most sustainable way forward, right? But also, I think that NASA shouldn't. I think that just getting out of the rocket game will end up causing a huge defund to the spaceflight economy completely, right? Like, you can say whatever you want about SLS, and yes, it does carry a heavy price tag, SLS Orion, but that is aerospace engineers that are bolstering our industrial base. That makes the space economy bigger. You could say, well, the public say, yeah, you could say jobs program. Yeah, you'd probably be right. But you got to remember that NASA getting out of the game of engineering their own rockets is a catastrophic destabilization of the spaceflight economy. You're putting thousands of aerospace engineers out of work and flooding the commercial market with that. I don't think that's wise. I really don't. I don't think that's a good idea. I think the system needs to be fixed, and I refuse to believe that it can't be.
I see. I see arguments on both sides. I'm not sure where exactly I would fall on that. Although, one would hope, in your doomsday scenario, EJ, all of those engineers that then flood the market go on to make startups of their own that innovate and disrupt in ways that they couldn't at their entrenched corporate origins. But
yeah, Jack.
Okay, but we're getting a little bit off. Like, what is your vision? Because I asked Trevor what he's now. Okay. What your Senator, Administrator, and Astronaut Bill Nelson? What's your vision? How do we fix it?
Okay, so yeah, I agree. We could sit here and whine about it. The right question to ask is how do you fix this? Honestly, at this point, I'd pull PPE and Halo. Just get rid of it, or put it back on SLS. But now you're screwing SpaceX out of a Falcon Heavy launch. I'm pretty sure they'll have something to say about that. Why do we have this? Why? Or just at the very least, put the PPE up there, use it as a relay, and do exactly what Apollo did. The Apollo program looked at the idea of putting a station into orbit, and they saw all the gravitational perturbations that happened and said, "No, we're not doing that. Let's just go down to the surface." Right?
Yeah, we do have a bunch of really good questions, and one of them was, why not just remove the crew? This is Kyler saying, why does Gateway need to be crewed? Why can't it just be a comms relay in Halo orbit? Like, that makes way more sense to me. Put a comms relay in Halo orbit, bam. Then you have comms constantly to the Earth, no matter where you are on the surface of the moon. But you don't have to put an entire freaking station there. Anyway, my vision would be...
Yeah,
my vision would be Moon by the end of the decade, Mars by 2035. Or if you want to be more realistic, it would be Moon by the end of the decade, Mars by the end of next. Like, anything else that prolongs that timeline is a distraction, and we just let's get there, and we'll evolve the situation from that. Like, we don't have to have a Ferrari parked in some exquisite boutique non-GMO like organic orbit. Like, we can just have it in a nice equatorial orbit. It's fine. We don't have to land at the South Pole of the moon. We can land near the equator. It's fine. Like,
South Pole is more. The South Pole is a good spot for a base, but we got to figure out where that ice is. Oh wait, we just canceled the rover that's supposed to do that. Whoops.
Hey, but we're sending a block of concrete instead, so that's
I'm sure that's really good at finding ice.
Hear me out. When the concrete hits the surface where the ice is, it will throw up a bunch of ice into the lunar atmosphere, for lack of a better word, and then we can be able to detect the ice using LRO and whatever else is orbiting the moon. Hey, then it served its purpose, right? Right?
Oh man, you are making me so angry.
I'm sorry.
Even sarcasm, man. I'm just like, ugh.
So NASA Administrator Jack says that we just need a date. We need a date, and we need to hold it.
Well, it's not just that, like, we need a date. You need a date, and then you need to take that date seriously enough that the downstream effects of that are, throughout the entire program. Like, hey, if we're going to get there by 2030, we have to, build it this way, or we have to sacrifice putting it in a different orbit, or we have to make it, not as nice. I mean, the Apollo program went to the moon and landed. I think of the LEM, and it's like, oh yeah, don't poke that wall. It's basically foil, and it's like, yeah, we should go back with all of the modern technology that we have today and do it right and do it better. But at the same time, like, we don't need to take a freaking Ferrari. Like, let's just go. Can we just go and start doing science, please?
This is one thing that I think, this is where I really think SpaceX's tremendous advantage comes from, is at the top they have Elon, who, even if you're a little bit late, he gets mad. And when he gets mad, he starts going on these, cost-cutting rampages of getting rid of any inefficiencies that he sees. And sometimes, it does seem like it's probably more than is absolutely necessary. But I really think that kind of helps motivate the employees to an extent that we haven't seen in any other company or any other organization probably since, like, Apollo in the Cold War.
Trevor, my question to you, I mean, you kind of answered it at the end there, dude, but my question to you is, do you think, I mean, there's no reason why NASA wouldn't be able to do something like that. You just need some accountability. And I agree, for what it's worth. Elon running a tight ship like that is why SpaceX is successful.
There's a thing in filmmaking. I always got to go back to putting my film nerd hat on. There's a thing in filmmaking